Welcome back to Techcademy Labs. Today, we're going to explore one of the most important concepts in networking, IP addressing. Whether you're here to improve your networking skills or prepare for your certification, this is the foundational knowledge you need. Before we jump in, don't forget to subscribe to the channel and hit the bell icon so you never miss out on our future lessons. Now, let's dive right in. An IP address is like the unique home address for a device on a network. It helps identify where data is coming from and where it's going, just like how your home address allows mail to reach you. There are two main types of IP addresses: IPv4, the most commonly used version, with a format like 192.168.1.1, and IPv6, the newer version, designed to support the growing number of devices, with a longer format like 2001:0DB8:85A3:82E:370:73334. These addresses ensure that data reaches the correct destination efficiently. Let's start with IPv4, since it's the most widely used. An IPv4 address is a 32-bit number divided into 4 octets separated by periods. Each octet is a number between 0 and 255. This system allows for over 4 billion unique IP addresses. For example, the address 192.168.0.10 represents a specific device on a network. This is a common private IP address used in many home networks. Devices can have either public or private IP addresses. Public IP addresses are unique across the entire internet and are assigned by your internet service provider, or ISP. Private IP addresses are used within local networks and cannot be routed on the internet. These are common in home and business networks. For example, in your home, devices like your laptop or smartphone may have private IPs, like 192.168.1.2, while your router has a public IP to communicate with the outside world. This distinction helps manage and secure network traffic efficiently. Because the world has more devices than IPv4 can handle, we also have IPv6. IPv6 is a 128-bit address system, allowing for an almost unlimited number of unique addresses. While IPv4 might look like 192.168.1.1, an IPv6 address could be 2001.DB885A3:882E:370:73334. The switch to IPv6 helps ensure that we won't run out of IP addresses in the future. This transition is crucial for the continued growth and stability of the internet. IPv6 also brings improvements in security and performance, making it essential for modern networks. As we continue to connect more devices, IPv6 will be the backbone of our digital future. In IPv4 addressing, IP addresses are divided into different classes. This helps organize networks based on their size and purpose. There are 5 main classes. Class A, for large networks. Its addresses range from 1.0.0.0 to 126.255.255.255. Class B, for medium-sized networks, with addresses from 128.0.0.0 to 191.255.255.255. Class C, for small networks, with addresses ranging from 192.0.0.0 to 223.255.255.255. Class D, used for multicasting, and Class E, reserved for experimental purposes. For example, a Class A address might be used by a large corporation, while a small office might use a Class C address. Understanding these classes is crucial for efficient network management. To make IP addresses more flexible, we use CIDR notation, or classless interdomain routing. It allows us to break away from the strict class system and allocate addresses based on need. For example, 192.168.1.0/24 means the first 24 bits represent the network, while the remaining bits identify individual devices within that network. This flexibility is crucial for efficient network management. CIDR helps in optimizing the use of IP addresses, making networks more scalable and easier to manage. There are two main ways devices get their IP addresses. Static IP addresses are manually assigned and don't change. These are often used for servers or devices that need a fixed address. Dynamic IP addresses are assigned automatically by DHCP, or Dynamic Host Configuration Protocol. Most home devices use dynamic addresses because they're simpler to manage. For example, when your laptop connects to your Wi-Fi, it usually gets a dynamic IP address like 192.168.1.5, which could change the next time you connect. This flexibility makes dynamic IPs ideal for most home networks. When devices communicate, they use their IP addresses to send and receive data. This is done through packets, which are small chunks of data that include the sender's and recipient's IP addresses. This is how your computer knows where to send an email, load a website, or transfer a file. Routers and switches help direct these packets to their correct destinations. In a basic network, devices need to have the right IP address settings to communicate. This involves configuring IP address, the unique identifier of the device. Subnet mask defines the network and host parts of the address. Default gateway, the router's IP address, which connects the local network to the internet. DNS server, the server that translates domain names like www.google.com into IP addresses. For instance, if you're setting up a device with a static IP, you would manually enter these values. This ensures proper communication within the network. Additionally, verifying these settings can help troubleshoot connectivity issues, making sure each device is correctly configured. IP addresses are crucial for network security. Firewalls, for example, use IP addresses to control which devices can access the network or the internet. To protect your network, it's important to keep track of IP addresses and apply the right security rules. For example, you might block certain IP addresses to prevent unauthorized access. Regularly reviewing and updating your IP address security measures is essential for maintaining a secure network. To recap, we've covered the basics of IP addressing, including IPv4 and IPv6, public versus private IPs, dynamic versus static addressing, and basic network configuration. Understanding these fundamentals is key to building a strong foundation in networking. If you found this video helpful, don't forget to subscribe to Techcademy Labs and stay tuned for more lessons that will help you master networking concepts. Thanks for watching.